In this class, let's learn accuracy, precision, significant figure, rules of significant figure, rules to find significant figure or to decide significant figures, and rules of significant figures for addition, multiplication, division, subtraction, operation. So questions on these topics are found in previous year KCET, COMEDK, PSAT like exams, including NEET. Okay, shall we start? Accuracy. Accuracy of a measurement is the measure of how close the measured value is to the true value of the quantity. How close it is to the true value. That's accuracy. Precision. Precision of a measurement is with what resolution the quantity is measured. How small it is, how precise it is. So let us understand these two using two examples. Okay. Now, here is line A. Task is to draw the line on A. So one student will do, or he will pick a pen and he will draw B. Look at the thickness B. One more student will take a pen and he will draw C. Look at the thickness, that is C. Now what is the task? Task is to draw the line closer to A or on A, not closer, on A. This B is closer to A means B is more accurate and C is less accurate. But C is drawn with fine tip. This is more precise. This is more accurate. So let me mention that. This is more accurate and this is more precise. So how small it is means high precision. You might have seen in workshops, high precision instruments are used. High precision work means that's related to the machine. Accuracy depends on the worker. Worker means the operator of the machine. Machine, precision. Worker or the handler, accuracy. Now, one more example. There is a target. Idea is to shoot the target, isn't it? So, first pistol or rifle uses these bullets, and second type this. Look at the size of the bullet. Size is big means low precision. This is high precision. But which is more closer to the bullseye? Bullseye means center. This is closer to the center means this is more accurate, less accurate, more accurate, less accurate, more precise, less precise. So that's how you have to decide. Now, rounding off a desired number of significant figures. For time being, neglect this. How to round off a number? Suppose there are 4 digits and I want only 3 digits. How to neglect this? How to round off that number? If this is greater than 5, add 1 to the previous. If it is less than 5, retain this as it is. That is first rule. Second rule, if this is 5, what should we do? Now, let us go through these examples. 8 greater than 5, add 1 to the previous, 34.7. 3 less than 5, retain, 123.4. 6 greater than 5, add 1 to the previous, 65.4. 4 less than 5, add 1 to previous, less than 5, retain, 2. So this is how we have to use under these two conditions. Next condition, what if the number is equal to 5? What if the number is equal to 5? Look at this, 5. In that case, it's a convention, that's all, okay. If the previous digit is even, then retain that as it is, 43.6. This is 5. If the previous is odd, then add 1 to this, 0.4. If it is odd, add on to this. If it's even, then retain that as it is. Now 5. This is odd. If this is odd, 4.6. 5. Previous is even. 0 is considered as even, right? Then 75.0. So this is how we have to use. Now one more set. 2, 4, 7. Now, how to round off this? This is greater than 5. Add on to the previous. Make it 2, 5. But you should not drop this. This is 0. 2, 5, 0. Okay. 1, 2, 3, 4. Now, this is less than 5. Look at the previous 3. Retain that. This is 123, 0. We should not write 1, 2, 3. We should not simply drop this. We should not drop it. But instead of 4, I have to use 0. So this is wrong. So this is how rounding of a number should be done. Few more examples. And through these examples, just practice. 6 greater than 5. Add on to previous, 123.5. Right? Correct. 4 less than 5. 2, 3, 4.8. Retain this 8 as it is. 5 greater than, less than, no, equal to 5. Look at the previous number. Previous is odd. Number. If it is odd number, add on to this, 365.2. 5. Previous is even, 2.72. 9 greater than 5. Add on to previous, 4.25. This one, 6.82. Hope you understood. This 0.22. Correct? 5. Previous is odd, 0.56. 0.13. No, previous is odd, 14. 0.75. Even, 76. This is how you have to use. Now, whatever I have explained, that same thing is there in the rules. Okay, just go through the rules. Significant figures. It is the precision of measurement. Significant figures is the number of digits accurately known in any measurement. Larger the number of significant figures, more accurate is the measurement. 140 kilometer. Using some method, by keeping map, ruler and reference ruler, we found out that distance between two cities is 140 kilometer. That's fine. 143 kilometer. So using much more precise method. 143.24 kilometer. See, even these two digits are considered, means two more significants are introduced. That is the meaning. That's how we go behind significant figures. Larger the number of significant figures, more accurate is the measurement. Fine. Reliable digits plus the first uncertain digit are known as significant digits or significant numbers. In this 143 kilometer, these two are reliable. This is the uncertain digit. Including these two, we have to say there are three significant figures. The last one is the uncertain. There could be two uncertain digits. Means in some measurement, in some other method, if this measurement is 152 kilometer, then these two digits are uncertain digits and this is reliable digit. So including uncertain and reliable, number of significant figures are counted. Fine. That's according to these two statements. Now get back and let us find significant figures of different numbers along with rules. Okay. To find number of significant digits, all the non-zero digits are significant. See, 1432 or 1.432. So all the digits are significant. 4. There are 4 significant digits. Come to this. All zeros between two non-zero digits are significant. See, this 0 is between non-zero. This 0 is between non-zero. Consider that 0 also. So there are 4 significant digits. There are 3 significant digits. Why we are targeting 0? That you will understand here. If a number is less than 1, all zeros to the left of non-zero number and to the right of decimal point is not significant. Less than 1, 0 point something, 0 point something, less than 1. All zeros to the left of non-zero, to the left of non-zero, and means these 3, this single. So these zeros are insignificant. Therefore, there are 3 significant figures. There are 2 significant figures. This is true if it is less than 1. If it is 2.003, see, this is greater than 1. In this case, these 4 are significant. These 4 are significant. Okay. All zeros at the terminal are insignificant, are not significant, are insignificant. But if the zeros come from a measurement, then they are significant. See, this has only 2 significant figures. Forget these 3 zeros. But after measurement, if we get 0, suppose length of the pen or pencil, after measurement, it turns out to be 10 centimeter, means this 0 is, consider that 0 because it is by the result of some measurement. So 10 centimeter has 2 significant figures. It's after measurement. There is a slight confusion, right? Still, when questions are based on this particular topic, they will be very clear with the concept, or they will be clear with the question. Don't worry about that. All trailing zeros in a number with decimal point are insignificant or significant. Fine. See, this 0 is significant. These zeros significant. 0.1. There is one significant figure. 0.10. These 2 are significant. 0.100. These 3 are significant. 0.1000. These 4 are significant. If the zeros appear after this, all are significant. If it is 25,000, only 2 are significant. In this case, these are insignificant. In this case, they are significant. You don't have to worry about these statements, but you should know the rule. Okay. These questions are not asked. Mention that rule, mention this rule. No. Instead of that, they'll give number and they'll ask you to find the number of significant figures. And there is one more type of question that let us follow later. The digit 0 conventionally put on the left side of decimal number less than 1 is never significant. Means usually we write 0.23. This 0 is not considered. 0.23. Sometimes when we write it on a book, we tend to neglect this, or we tend to this may go unnoticed. If this goes unnoticed, in order to avoid that, we tell students to write like this, 0.23. So only for that reason. Okay. So this is insignificant. Now, the multiplying or dividing factors which are neither rounded numbers nor the numbers representing measured values are exact and have infinite number of significant figures. For example, 243, 10 to the power of 4. This is one way of representation. Same thing can be written as 2.43, 10 to the power of 6. This is equal to this. Look at the power, 10 to the power of 6, 10 to the power of 4. How many different ways we can write this? Means there are infinite numbers. So that is why we don't consider these. This has 3 significant, this has 3 significant, that's fine. Don't worry about these two. That's the meaning of this statement. Now, through these examples, let us apply all the rules. It's easy, okay? Trust me. Less than 1. Only these are significant. 1, 2, 3, 4, 5. 5 digits are significant. Good. These are significant. 2, 3, 5 digits. All are significant. 1, 2, 3, 4, 5, 6. All are significant. 6 digits. All are significant. 6 digits. All are significant. 5 digits. All are significant. 5. Only these two are significant. 2. These are significant. 1, 2, 3, 4, 5, 6, 7. Come to this. These are significant. 3. Only these 3 are significant. 3. Forget. These 2 are significant. Forget. These 4 are significant. Forget. Only this is significant. Forget. These 3 are significant. Forget. This one. Only 1. 3. These 4 are significant. Right? Now, all are significant. Only these 2 are significant. 4 are significant. All are significant. Correct? These are significant. All are significant. Only this is significant. All. I tried to cover all the types. Good. If you have slight doubt, just start from this and observe all the numbers and the corresponding significant figures. It's easy. After this, let's go to rules of significant figures in addition, subtraction, multiplication, division. Rules for arithmetic operations with significant figures. Significant figures in addition and subtraction. In addition or subtraction, the final result should retain as many decimal places. It is targeting on the decimal places as there in the number with least decimal places. Good. Let me explain this using an example. 12.23 plus 2.4. We have to add these two. Answer is 14.63. Just add 14.63. But when we use the rules of significant figure, after decimal point there are 2 digits. After decimal there is only 1 digit. Least is 1. So there are 2 digits here. So this should contain only 1. Means we should neglect 3. How to neglect 3? 3 is less than 5. Less than 5 means just drop it. Make it 14.6. See, there is only 1 digit after decimal point. That's how we should do. Now come to this. 12.23 minus 2.1. Subtraction. This results in this. There are 2 digits. There is only 1 digit. Difference of these two is this. It has 2 digits. It should contain only 1. So 3. 3 is less than 5. Less than 5. So just drop it. Make it 10.1. This is the answer. So that's how rules of significant figures are introduced. What is the actual meaning of this means? Consider this. Okay. Rules for multiplication and division. And before that, few more examples. Addition. This plus this. 222.225.44825. When we add these two, we get this, right? 25, 25. 4 plus 4, 8. 2, 3, 5. But there are 3 digits here. There is only 1 digit. 1, this is 3. There are 3 digits here. This should contain only 1 digit. So 5, look at the previous number. This is even. So instead of this, write 225.82. It should contain only 1. This is less than 5. Just drop. 225.8 is the answer. So for this, 225.8. Now, second, 4, 4, 3, 2, 5, 4, 4, 8, 3, 4, 7. This is 3. When we add these two, we get this. There are 2 digits. There are 3 digits. 3 and 2. Least is 2. This 4 is less than 5. So just drop it. Make it 37.85. So this is the answer. Now add these two. 0.335. There is 1 digit. There are 3 digits. Least is 1. There are 3. 5. 5 is, look at the previous. 3 is odd. Add on to this. 0.34. Still it has 2. 5 is less than, this 4 is less than 5. So drop it. 0.3. 0.3 is the answer. 0.3. Now this, there is 10 to the power of 3. Now just add these two. 424.34 and then 123 into 10 to the power of 3. Anyway, we have to drop this. There are 2 digits. There is only 1 digit. So answer should contain 1 digit. 4. 4 is less than 5. Therefore, drop it. 123.3 into 10 to the power of 3 is the answer. We have to retain this because that doesn't come under significant figure. So answer is 123.3 10 to the power of 3. It is not there means that doesn't mean you have to drop it. You retain. Anyway, we are not counting that under significant figure. And 123.34 becomes 123.3. Now, significant figures in multiplication. How to use in multiplication? In multiplication or division, the final result should retain as many significant figures as there in the original number with the least number of significant figures. Now, it's not the number of digits, it's the number of significant figures. 21.1 into 4.0 gives 84.4. there are 3 significant figures, 2 significant figures. Least among these two is 2. Product of these two is this. There are 3 significant figures. We should have only 2. 4 is less than 5. Drop it. 84. This is the answer. One more example. This into this. 84.5. 1 significant figure, 3 significant figures, least is 1. This has 3 significant figures. 4 less than 5, drop it. Again 4 less than 5, drop it. In place of this write 0. See, this has only 1 significant figure. 1 and this is 1. So this is the answer. Significant figures in multiplication. Few examples. When we are solving this, we should understand and it should be a practice. 12 into 4.0, 48.0. There are 2 significant figures. There are 2 significant figures. This has 3 significant figures. Therefore, answer should be 48. There are 2 significant figures. This is equal to this, but not under rules of significant figures. Okay. 12 into this is 480.0. 3, 2, least is 2. This should contain only 2, means 2. Instead of this, we should write 48, 0. So this is equivalent to this, but this has only 2 significant figures. This is the answer. Now, 12 into 40, 480. 480. 2 significant figures. 2 significant figures. This has 2 significant figures. Correct. Instead of this, I cannot write 480.0. 480.00. On a scale, 480.0 millimeter is same as 480.00 millimeter. But for calculations, we have to consider number of significant figures. According to that, this is correct and these two are not correct. 111 into 5. 5, 5, 5. 1 significant, 3 significant, least is 1. 5. Previous is odd. Add 1 to this. Make it 560. There are 2 significant. We want only 1. So 6. 6 is greater than 5. Add 1 to previous. Now, 111 into 5.0. 5.0. 2 significant, 3 significant, right? There are 4 significant. 5, previous is odd, add on to this, make it 560. Product of these two is 560. There are only 2 significant figures. Come to this, 111 into 5.00. 5.00. 3 significant figures, 3 significant figures. This has 5 significant figures. So drop these two, just write 5, 5, 5. 3, 3. This also has 3 significant figures. 11.1, 5.5. 3, this is 1. This has 3, therefore 5, or consider 55. 55 is greater than 50. So add on to previous. 60. 55.5 is closer to 60. 60. only one significant figure. 1 and this is one significant figure. So this is multiplication with respect to significant figures. Now scientific notation. In this notation, every number is expressed as a into 10 power b, where a is a number between 1 and 10, between 1 and 10, and b is any positive or negative exponent or power of 10. Here b is called order of magnitude. This is called order of magnitude. This is of the order of, right? Suppose 243 10 to the power of 5. Instead of writing like this, 2.43 into 10 to the power of 6. See, this number is between 1 and 10, and this is order of magnitude. So order of magnitude is 6, of the order of 10 to the power of 6. So this is how we have to write the number according to this scientific notation. Of course, this is equal to this. Outside scientific work, we can use this or this. People will understand. But here, along with understanding of the people, we have to follow rules, set of rules. Why we have to follow rules? To communicate properly with other people who are in the same field. For that reason, we have to use like this. Even after solving problems, in the last step, when you are writing the answer, make sure that you use the scientific notation. If you don't use also, you will get marks. But it's my advice, please use such notation. Suppose 0.004 centimeter is the final answer. Write this as -1, -2, -3. 4 10 to the power of -3 centimeter. And if you are taking care of significant figures, this is the answer, because this has one significant figure, one significant figure. This is same as 4.0 10 to the power of -3 centimeter. But this has two significant figures, whereas this has only one significant figure. So there is lot more fun involved in using scientific notations. You should not think that it's a torture. Please, it is not a torture. It is fun following rules.